The aim of this video is to show some possible ways you have for doing a visual investigation of the distribution of the donor and acceptor cells when an overset case is running. The case described here is about a rudder with a prescribed periodic motion. In this case, you have to define two regions, an external box for the background and an internal box, including the rudder, for the overset. The periodic motion is defined by the field function rudder rotation rate. The rudder rotates between 35 and minus 35 degrees and the period is 2 seconds. In order to let the overset region rotate, you have to define a new motion. Use the already mentioned field function as the input for the rotation rate and set the rotation axis by using the correct coordinate system. The first thing you have to do is verify if the mesh refinements on both regions in the overlapping area satisfy the overset interface requirements. You can do this by defining properly oriented section planes in the most relevant locations. In this example, you can see that 3 section planes oriented along the 3 main axes have been already created. By default, when you use the tool Create Section Plane, Star System Plus automatically selects all the available regions as input part. If you now create a mesh scene selecting those section planes as input parts, you will see the meshes in both the background and the overset region at the same time and with the same color. This approach does not result particularly useful in the overlapping areas because it is difficult to distinguish the faces belonging to the overset from the faces belonging to the background mesh. In order to make the scene more clear, you can duplicate the existing plane sections and select only the background or the overset region as input parts. Using the suffix background and the overset for the name of the displayers could be very useful. Now you have to manipulate the existing mesh scene in order to create one displayer per each mesh you want to show. Duplicate the existing displayer and rename it Overset. Rename the other displayer Background. In the background displayer, replace the existing input parts with all the section planes you named Background. And do the same for the input part of the overset displayer. Now you can change the settings of the overset displayer, hiding the surface and changing the color of the mesh lines. The two meshes are now easy to distinguish in the overlapping area. The same section planes can be used to create a scalar scene and visualize the overset cell status scalar function. To make the scene clearer, you can hide the outline displayer. Create one displayer for the X, Y and YZ background planes and select the overset cell status field function as input for the scalar field. Duplicate the existing displayer and change the input parts by adding the XZ background plane and removing the other two. Change the opacity to 0.5 to make the plane transparent. The scene now shows the red inactive cells, the yellow active cells and the blue donor and acceptor cells on the 3 main planes. In order to let the overset work, it is fundamental to have a continuous ring of blue cells. This scene can be visualized during the run and can tell you if and where issues may occur. Another scene that could be useful for debugging purposes is the one in which you visualize only the donor and acceptor cells. You can do that by defining a threshold. Donor and acceptor cells are characterized by an overset cell status value equal to -2, and you can use this information to set the criteria for the threshold. In the threshold settings, you have to select all the regions of your simulation. The overset cell status as a scalar field function, be sure that the search mode is below min, and set a value greater than -2 as input for the range field. You can now create a new geometry scene with two different geometry displayers. In the first one, you select the body as input part. In the second, you select the threshold just created and change the color and the opacity in order to make the scene more clear. With this scene, you can verify if the body is always surrounded by the threshold. This means that the donor and acceptor cells are always correctly detected and defined. Recording all those three scenes during the run can result useful when your simulation is affected by an issue related to the overset interface and you want to find the area where the mesh needs improvements.